Can you all hear me in the back? I just want to make sure. Okay, good. All right, so thank you everyone for joining today, and thank you to all of the people who set up GopherCon Australia. I'm really grateful to be here, so thank you for that. Welcome to my talk, Back to the Future, Modernizing CLIs with Go. So first, a little bit about myself. I am a senior software engineer at Netflix, where I've been working for the last 4 years. So I'm also a polyglot programmer. So at Netflix, I code in Java, JavaScript, and Go, but Go remains my favorite language. Also, earlier this year, I published my first book with Pact, Building Modern CLI Applications in Go. So today, I'm going to take the opportunity to share some of my knowledge with you. And in a fun twist, and because art is a passion of mine, I'll be drawing parallels from the iconic sci-fi classic Back to the Future. So just as a show of hands, how many of you have seen this movie? Okay, great. I'm glad a lot of you have seen it. But if you haven't caught it yet, it's a must-watch from the 80s. And it's all about a teenager, Marty McFly, and his inventive pal, Doc Brown. Together they embark on some time-traveling escapades in a DeLorean. Definitely worth a movie night. And this is the time-traveling DeLorean that will take us through time to show us how we began and how far we've come with how we interact with computers. The first place we travel back to is the 1950s. So in the movie Back to the Future, Marty McFly travels back to 1955 to change the course of time to save his future. Similarly, in technology, we can go back in time or look back in time to gain a new understanding, to understand the present, and to build a better future. So in the 1950s, computers were massive machines, and people primarily interacted with them using punch cards. So people would use these punch cards and then punch code into them, and then the computers would process them in batches. There was no real-time feedback, so you'd submit your cards and then eventually receive printed results. So reflecting on that, we learn the importance of a tight feedback loop, which informs modern CLI design to be immediate, responsive, and user-centric. By the mid-1980s, the computer landscape had shifted dramatically. People were typing commands directly into command line interfaces, and then they were receiving real-time interaction. At the same time, graphical user interfaces were emerging, similar to the early versions of Windows. So people would click on icons and use Windows to navigate through computers. So computing became more visually intuitive. But here's the amazing thing about CLIs. They've persisted. We still use CLIs today, and they've become more powerful than ever, with engineers choosing to use them even more so than their graphical user counterparts. And they're often an additional offering next to a services API. And why is that? Well, CLIs are favored for their efficiency and raw power, streamlining tasks and promoting automation. There's minimal overhead, so you're ensuring that there's rapid execution, and they also grant users a higher degree of control. Moreover, their portability allows them to be run on diverse environments. So in Back to the Future, the time-traveling DeLorean required a power source, the machine's flux capacitor, which is a fictional piece of technology that held all of the power needed to make time travel possible. Similarly, our journey to modernizing CLIs requires a robust, efficient, and reliable power source. And in our world, that power source is Go. So let's dive into why I think Go is a great language for building your next CLI. So back in 2014, I started teaching myself Go, but it was alongside other programming languages. And what I noticed was that the code that I was writing, even though it was a similar task, was a lot simpler. Just in design, I fell in love with the fact that the code came out much cleaner than in comparison to other languages. So its simplicity really got me, and that's what took me forward to where I am today. Next, the language is garbage collected. So that means one less thing for you to worry about, memory management. The concurrency model within Go is really unique because a lot of the complexity is abstracted out with Go routines and channels. There's explicit error handling, so within your functions, you don't have any exceptions that are occurring where you need to do a try and a catch around that. Also by design, I think that as a Go programmer, you want to handle your errors, so you don't want to ignore them. Some people do, but it's really important to handle them explicitly. Also, the configuration for cross-compilation is really simple in Go, which I love. So that makes it really great to be able to write your CLI and then be able to port it out to different operating systems and architectures. And finally, the community. So I love giving talks here at GopherCon and meeting other coders that are writing Go code. And if you see me just walking around, just please stop and say hi. I'd love to meet you and chat about anything Go or not Go. It's just nice to meet everyone. Also, if you're not a part of Gopher Slack yet, if you're a new programmer, I definitely recommend joining Gopher Slack. If you have a question, you can put it in the general channel. Usually there's engineers who are more experienced that can help you out, and also there's someone who can, learn and benefit from that thread. So let's jump to 1985's Hill Valley from Back to the Future. Remember Marty McFly's puzzlement with the DeLorean? But after Doc Brown's guide on its operation, all became clear. Just like Marty, without guidance, we'd be lost in a CLI. So first, the golden rule is human-first design. Prioritize intuitive design by sticking to familiar commands. Maintain consistency in syntax to prevent user confusion. Think of our CLI as Doc Brown, always ready to offer guidance and handle surprises. So provide helpful feedback when the user needs it, and also documentation to ease the learning curve. Make the experience conversational with interactive prompts. And don't forget, while our output should cater to humans, it's always important to make that output adaptable. So to change whether or not it's outputting in JSON or YAML, or even to disable the prompts, because sometimes your CLIs will be used and embedded within other scripts, so you want to add some configuration ability within that. All right, time travelers, let's talk about naming. The DeLorean's license plate was out of time, which was definitely memorable, and it encapsulated exactly what the DeLorean did. It was a time traveling machine. So let's bring that thought into our command line interfaces. The name of your CLI should be intuitive. So provide a name that really encapsulates exactly what your CLI's purpose is. You want it to be simple as well, so a longer name is much harder to remember, as well as a more complicated one. One could even say that out of time is a bit unclear. So if I were to build a time traveling CLI, I would just name it what it is, time travel. Can't get simpler than that. The name should contain no special characters, so adding these special characters might seem edgy or fun in the moment, but it's neither intuitive or user-friendly. In essence, when naming your CLI, make them memorable, make the name clear, and above all, keep it user-friendly. So now let's talk about input. The way we structure our input isn't a random decision. It follows a logical pattern, much like the structure of a sentence in our everyday language. So we start with application. Just like you were to get someone's attention and call them by name, similarly, application sets the context for the commands we are about to call. Now this gets interesting. Noun versus verb, verb versus noun. Think of it like asking someone to open the door or door open. So whichever one you choose, it's just a good idea to stay consistent within that flow and use noun versus verb or verb versus noun that makes sense. So you'll understand that when you start building your CLI. Next is adjectives. So adjectives add flavor to our language and they add specificity to our commands. So within CLIs, those adjectives come in the form of flags. Think of it in terms of natural language as to open the door slowly. That slowly adds the specificity to our command. In essence, crafting a CLI command is almost poetic. It's about choosing the right elements and structuring them in a way that's clear, efficient, and intuitive. Now let's put what we've learned into practice. On this slide, we're going to dive into a time-traveling journey, but in the world of CLIs. Remember, it's all about crafting a poetic and logical command. So let's look at our first example. Time travel to 1985. Time travel, this is our application name, setting the stage. 2 acts as our bridge between our action and the destination. Then 1985 is our parameter. This is the year we want to head to. Next is time travel, pause, -- duration equals 2 hours. Again, we start with our application name, time travel, and duration is the flag, and then we set the specificity of 2 hours. So in natural language, it would sound like, hey, time traveling application, pause time for 2 hours. And then finally, time travel return. So with this, again, our trusty application name, and return is our command that hopefully it makes sense to return back to our original time and space. So much like the unpredictabilities and disturbances in time travel, when building a CLI, we have to anticipate and gracefully handle unexpected interruptions. Imagine you're in the DeLorean cruising through time and suddenly you're struck by lightning. You'd want the car's systems to handle it smoothly rather than crash, right? In our time travel CLI, we use similar principles. Let's look at how we handle such disturbances, or in CLI terms, how we handle interrupt signals. So first, we set up a channel on which to send signal notifications. We must use a buffered channel or risk missing the signal if we're not ready to receive when the signal is sent. Next, we define which signals will be sent to the channel. So in this case, it's signal interrupt, signal terminate, and signal quit. If no signals are specified, then it'll receive all signals. And then finally, in this particular example, rather than blocking execution, we put the code to receive the signal from the channel within a go function. And once that signal is received, then we handle exiting gracefully, and then exit 1. Now here's output. This is a screenshot of the dashboard of the time-traveling DeLorean. So it gives us nothing more or nothing less than what we need, but just enough information. So it gives us the destination time, the present time, and the last time departed, just the month, the day, the year, hour, and minute. So how do we craft effective output? Let's start with some clear and concise feedback. The user should be able to understand the response and the action to take next. Any errors should be rewritten for human consumption. And then the structured options. So as mentioned earlier, you want to have output that changes based on who's receiving it. And I'll give an example of that and how to do that in the following slide. We want to separate our output streams. So any output to standard out, any errors to standard error. We want to be consistent with our format. That helps to visually group the data and be intentional with colors. So if you are going to add any color into your CLI, you want to be able to provide some information. For example, if it's a successful command, print it out in green. If there's an error, print it out in red. Progress indicators. So if there's any operation that's taking a long time, it can be really confusing for users to type in a command and then wait and then receive no feedback at all. So adding a progress indicator allows your users to see that something is going on behind the scenes. And then you want to add some comprehensive help options just in case that's not enough. All right, so interactivity. Prompts and interactivity should be for humans only. You also want to give the option to disable these prompts with, for example, a no input flag. And then if you have a terminal dashboard that you've created, allow the users to quit out of that. Also, prioritize security by hiding sensitive data. So now I'll be showing some of the code to check to see where the CLI is outputting to. And it's usually the case that if you're outputting to a terminal, or you can find out if you're outputting to a terminal, that a human is usually on the other end of that. But not always the case. But this is code that you can use to do that. So the first thing to do is to check the status of your standard out device. Next, you want to do a bitwise test against the os.mode char device to check if the output is a character device. If that does not equal to 0, then it's likely human interaction, but not always. All right, so imagine Marty and the DeLorean baffled by buttons and lights. It's how we feel with a confusing CLI, but thank goodness for that DeLorean time machine manual. We all need a guide sometimes. Users require a Doc Brown to show someone the ropes. In your case, the users need you to provide guidance through any of the following. Either a -h or --help command that gives guidance, or just like the DeLorean manual, we want to create a man page for our users, for our CLI. And then to go a step further, create a website with online documentation that could encourage some tutorials and discussions and where you can put examples for some advanced cases. But it's basically the internet hub for our CLI travelers. The goal really is to empower users, making their CLI journey smooth and effective. All right, so let's now do a demo, and hopefully this works. I know there's been some AV problems, so we'll give it a shot. Okay. All right, looks good. So the first thing that people usually do when they're faced with a CLI is to just run it with no input. So we do that, and we see that there's some help text. And that kind of gives us a base as to where to start. So there's two commands. There's the to command, which we were talking about earlier, and then there's also a feedback command. So I'm going to run both. There's also an example for that. This is an example that takes us into Back to the Future Day 1985. So I'm going to run that and see what happens. All right, the output is in text format. We have the ability to use a flag to change that to output to JSON, which it does, and then we can even use that to pipe into another command if we want. There's also another way that we can output this, and it's as a dashboard. So we run that, and it says that our destination time is Back to the Future Day, October 21st, 1985. And within the movie, for those of you who haven't seen it, the time-traveling DeLorean has to reach 88.8 miles per hour in order to warp into our destination time. So we're going to blast off and go. And once you reach 88.8 miles per hour, the time warp will be complete. All right, so let's go. Oh, also, we have a feedback command as well. And it asks, how's your journey? Well, it's quite small. I don't know if I can make that bigger. But adding some prompts in there will help to make the interaction with computers feel a bit more human readable. All right, so let's jump into the code and how this is done. So in order to create this CLI, I used a few frameworks. The first one that I used was the Cobra CLI. So just as a show of how simple it is, I already have it set up. So just running that, you have the ability to add a new command to an already existing project like I have. You can also initialize a new CLI project, which is really great. So it really helps to kind of get things set up very quickly. For those of you who want to use this framework, I recommend it. So I would just add, for example, Cobra CLI add pause if I wanted to add that pause command, and then it would take me to, I would go through here. Hope everyone can see this. So now you can see that just by calling that Cobra CLI command, it just automatically generates the scaffolding for the new command, and you can change all of this information. So we might add a description to pause time, and then a longer description, or within the run function, add something to check what the duration would be. And then we could also add a flag to the pause command within the init function. Before this CLI, I had already created these functions based on that. And you could see that we have the to function. It checks the different args, and it parses the destination, printing out an error if it's invalid format. And then based on the fact that I was showing the different ways to output, we have a switch statement that would check whether or not that output flag was set to the default, to JSON, to YAML, or the dashboard. So remember that code where I was checking if you're outputting to a terminal? I had put that within this utils function. So it'll check that. If it's not a terminal, then we can't use the dashboard, so it'll automatically return. And if not, then you can output the dashboard. And I'm using term dash for that, which I loved using. It's a great tool for building terminal dashboards. And for this, let's go to the dashboard that I've created here. So you have these segment displays, and then you can add text within the segment displays. And then adding a button is as simple as button.new, and then adding the text and what color you would fill it in with. There's some infrastructure with term box that you need to learn, but it's very simple. So you add new, and then you can create containers with different layouts. You could have a grid layout, but within this, I'm actually using a binary layout, which splits either horizontally or vertically. And then you just place those widgets that you've created in there. So this was the code for that DeLorean dashboard. Now we can talk about the feedback command. Now, there's a lot of other frameworks out there to basically prompt your user for information, but I just wanted to show that you could use basically what was in the standard environment for that. So within the survey command, I just display the menu that I was showing before, asking like, how's your journey? And then you're using a scanner to just receive the input, and then a switch statement on the choice to then print the result. So that's that. Also, within main, as I noted before, this is where you can handle signal interrupts. And we have this one line that says, time circuit's off, see you in another timeline. So let's just show how that would look as well. I think I have time for that. So say we start up this dashboard, and then there is an interrupt signal that comes through. So I think it's peak hill and then time travel. So what you'll see is just by killing that signal kill, that we have time circuits off, see you in another timeline. So that's pretty much it. I'm going to go back to my slides. All right, so here are the Golang frameworks that I've used. For the CLI framework, I used Cobra specifically, but if that's not your cup of tea, there's a your fave CLI. Also, the standard library offers a lot that you could use for adding flags. There's a lot that you can do. And then for dashboards, I specifically used the Term Dash framework, but there's also Bubble Tea if you want to use that. And then to add color, there's Fatigue Color. But there's a lot of options out there, so you have your choice. Finally, if you have any questions, then you can reach me via email or on Twitter. Feel free to rate my talk. There's some general guidelines for CLIs that are available on this great website called clig.dev, that stands for CLI Guidelines. So definitely check that out, no matter what language you're using to develop your CLI. Also, the demo code for this talk is available on my GitHub. And then if you are interested in the book that I just published, it has a lot of other fun examples, one that allows you to have an audio player to play music within your terminal as well, so it's fun. So, as Doc Brown would say, the future isn't written yet, no one's has. What we discussed today is just the beginning, and there's a whole timeline ahead to explore and shape. So keep coding, keep innovating, and remember, where we're going, we don't need roads. So let's shape the future of CLIs together and go. And thank you again. I'll see you in the future.